Welcome to another Random Code stream, whether you're watching now or in the future. I found a couple of bugs in rocks, and I need to move my camera down to the coding space. The camera goes up when I'm playing video games, but down here when I'm coding. So I found a couple of bugs, and the reason I found these bugs was because I have started to work on getting a 10.0 release, which is going to target .NET 10. By the way, I am not forgetting about this interception idea that I had before, but I just haven't. I don't think I'm going to have the time to really get it working before I go to Canada. So I'm just going to put it on the back burner until I get back. But I wanted to start working on rocks and having a target .NET 10 and seeing if there's anything that comes up. When I looked at there's two different general areas to look. One of them is the language, and the other is the runtime, the supporting APIs. And it's a little hard sometimes to see what's coming in new that could potentially affect rocks, because the fundamental thing that rocks needs to do is be able to inherit from a type and inherit from it correctly. And when you start dealing with new or hiding, or you deal with different kinds of types and nullability, and there's been so much over the years that features have been added that have inadvertently affected rocks, and sometimes some bugs come out of that. So I found a couple, and I don't know if they're .NET 10 related, but they are showing up at least in some of the packages that I reference, and one of them was Entity Framework, because of course Entity Framework does so many wonderful things. It's actually been a good source for me to find things out that, oh yeah, you can do this in C#, and oh yeah, that does break rocks. So in any event, I'm going to get my music going, and we're going to take a look at this first bug, actually the first two bugs, because I think I can solve them both with the same approach. So the first one is like this. This is actually new because of a base type, but it doesn't matter. We just say new here and it shows the error. And then we inherit from it. We also make a new of that property here. And the problem is that, and this will only show up when you do shims. And shims only show up in rocks when you have default interface members. Because rocks shouldn't force you to call this method if you don't provide an expectation. So I basically created this workaround because you can't call base dot for shim on a dim. It just doesn't work. So what I do is I create a type underneath the scenes that doesn't implement this, but implements everything else that doesn't have a dim. And then I can basically use that to call the default interface member. Well, that means the other members, though, have to have implementations. And so if, like in this case, what's happening is this base type property, not necessarily confusing rocks because you have to do both the getter and setter, but it's setting them to being mutable complex type, which is not correct. It should be, I think, mutable base type, or you can just not do it at all. Okay. There's another one that was very, very similar to this, and that's this one. So almost the same thing, except the deriving interface type has both a getter and setter. And what happens in this case is that, again, arguably it should always cast the mock to that type. But then I started thinking about this, and I went, wait a minute. When I look at what this shim code is generating, and if I go to an actual test to show what this is doing, generator shim. So you see that this interface has something that has a default implementation, which does nothing, but it is a default implementation. So what Rocks does is it will generate a type, it's private, implements this interface, but it implements the property. It does not implement the It does not implement the method. Okay. And you notice that it also takes a reference to the actual mock instance. So the way this works is if you come up here and you go, well, let's look at that method consume. If you don't set an expectation for it, what Rocks will do is call an instance of this, which has a reference to this mock instance, and call consume. That, in effect, calls the dim. So a little bit of misdirection, but it works. But I started thinking about it, and I'm like, why do these need to have any implementation at all? Properties, indexers, methods? They don't. They could all just fail. Just have them all fail. There's, have them throw an exception because they should never be called in the first place. Now, I was thinking about this too, and I went, have I gone down this path already? There's a part of my head that goes, I think I've tried to do something like this already. And it didn't work, but I'm going to try this first, because if I do this and it works, it's going to fix both these bugs in one shot. And that is to say, instead of doing something like this, like throw new, and we'll make a type in our shared Rocks library, shim implementation exception, something like that. Yeah. And we could get fancy and say, but you'll see it in the call set. The thing is, again, this should never be called. None of the things in here other than the mock type, nothing else should be called. Because there's no reason, like max buffer size here, if you look it up here, the getter never does anything with the mock. If it got called, it's because it expected you to actually set an implementation. Same thing with the initter. So I'm sitting here going, this should fix it. If I have all of these, even like the initters, everything, do something like this. That means something went very, very badly in Rocks, and something needs to get fixed. So that's what I'm going to try. I'm going to target this to one of the issues, but this actually will hopefully fix both. Now, this is also going to cause some code churn, because all the tests within this class, at least, will fail, because all of them now will have this, but I should be able to fix them all relatively quickly, hopefully, because I should be able to say they all throw this exception. All of them do. So we shall see. Again, this might be a complete mistake and not fix it. And if it doesn't fix it, then what I can do is something like, make sure that the thing that you're casting it to is of the type that you're implementing, or deriving from, unless you're doing an explicit implementation and then it has to cast it to that. That will be another way that it fixes it. So let's give this a roll. And I'm doing this off of my, you can't see it down below, but if I move my camera, you can see that my branch is this target.NET 10. So I'm going to do a branch off of this branch, because this is all .NET 10 working. So if something actually came in that was like a severe bug, I still want to be able to do a fix on the 9.3.0, the current main branch. So, all right. So let's fix it using this name. Again, hopefully this fixes both of them. So we'll say get new branch. Actually, do we need to commit anything to this? What's the difference here? Yes. So we do want to commit that. Get commit, and then this one. Yeah, I was just flipping around. That's fine. So we can say get commit. Update on 10 work. Commit that. Push that there, and now we shall say get new branch off of this .NET 10 branch. Okay, so let's set up a test that actually does one of these at least. So we'll say here, generate when shim has properties hidden. I don't really care. That's good enough. And again, you may go, how in the world, like, why would anybody do this? Well, go ask the EF team, because this was found on this type. So they did this. And again, it's not technically wrong. It's valid C# code. And they have the reasons as to why they're doing the things they do. So that is not for me to judge. I mean, I can judge, but because it looks odd, but they must have their reasons. Okay, so we need to go down here and grab all this. And I have to spend a couple of minutes making sure that I get the actual generated code. Okay, so now let's run this, and let's get the actual code snippets. The current Visual Studio oh, yeah, I need to, sorry. I need to be in 22 preview. That would help. Okay, and then let's... The size of the font should be fine. I think I need to jump it up a little bit there. Okay. Now let's run this. It should at least run, and then test should fail. I was like, wow, it degraded that it wouldn't do .NET 10. That would have been a bummer. All right, grab all this code. And it's amazing. Actually, I got to go to the test log. It is amazing how much code rocks generate. And you may go, well, that's really inefficient, blah, blah, blah. And it's like, well, no, it's doing it. I'm not saying it's completely efficient either. I am sure that if somebody dove in, they would find all sorts of things that I could probably improve upon with the performance of the code. I take pull requests. So I am always, if somebody can show me, like with a benchmark.net test, that if I changed the code to a certain way or did something that, yes, it would work better, I would absolutely take that. But from literally running this code base now for 10 years, and it's like with what it needs to do and how it does it, it's kind of like it is what it is. So now at this point we should be seeing the error. Okay, so if we come up here, you should see that yes, we're getting the explicit conversion. That's the error that we're getting. So how to fix this? Well, what we want to do first is in rocks here, we want to have like an exception like this. Okay. So, and again, I'm thinking I want a specific exception for this, because I don't want to just say not supported exception. I want this to be very specific to something went wrong in the implementation of the shim. Okay. So we shall say here that thrown when a member on a shim has been invoked. This should never happen in rocks. So we're trying to be very blunt about that. Okay. Now we want to also go into generating the code. So if I go into analysis, builders in the shim, there's basically, there's 4 parts. Events really don't count because there's no implementation. Well, there is if we have an explicit implementation. You'll see that in a moment, but the indexers, method, and properties are the ones that matter the most. So let's go to the method one first. And this is also going to potentially get rid of a whole bunch of other code that we don't need. Okay. So like you see all of this stuff kind of up here. This we do need, because this defines the method itself. And then this also has constraints because we need to put those constraints in there. But after that, why is it only the switch here? Populate switch. Why would I populate the switch? No, that's a terrible thing to suggest. Awful. Bad, bad. Okay. But all of them come down to basically doing some kind of cast to pass in everything to the base type. And that's what we want to change. We want to say here, writer.writeLine. Throw new global rocks exceptions dot shim implementation exception. There. And so that goes away. We don't need the pass parameters anymore. What else don't we need? The constraints we need, the accessibility we do need, the type arguments we need. But that's it. At this point, it will just throw. Okay, and I'm going to actually copy this line here because we want to do this for now. Properties. So properties here, this is where we have the getter and the setter. Okay, so we want to say get that and set that. So we could also say here throw new global rocks exceptions dot shim implementation exception. And the rest of this goes away. And we also don't need that. So ref return is no longer needed. Okay. And then we can say set here as well, except we need to say set. And then this becomes a init. But all those throw an exception. Okay. So we do need the accessors. We do need all this stuff to happen because that's all up here. That's all done in generating the property information. Okay. But that should now take care of the properties. The indexers, again, will be also similar in that we should be able to say here that. And then we say the same thing for set. And init. Except that needs a big arrow. So we should no longer need parameters. Right? Get rid of that. Probably need return by ref because that needs to be in there. Okay, yeah, that's all fine. But now indexers will do the same thing. So it's not a big change in terms of performance. Now events are a little weird. So you see here that if we can build an implementation that just has the event declared here, this one, if it's an explicit implementation, I think I ran into this and you have to do this. But I'm also kind of like, you shouldn't be running into these things. You shouldn't be actually calling these things. So, I don't know. I'm kind of like, I think I'm going to leave this for now, but we'll see what this does. Okay, so we're going to do a clean succeeded. Now what I'm going to do is actually jump to the code generation test. Because what I want to do here is say, let's go to the program. We have a test with type. And this was in read-only tensor. That's another issue that we have to address. But let's put this one back in there. And let's see if that fixes it. Because this will just generate for this type. Okay? We are calling test with type. So let's run that and see what happens. No error. Okay, that's good. What about the one on 389? That is another entity framework type. This So let's go to that one, change that, and let's run that one. That also works. Okay, let's go to integration tests, because we should have some shim tests here, right? Well, we do, but this won't actually show it. That's interesting. So, but this still works, right? If I put a ID, a GUID ID, get, and a init here, now that should have regenerated it. It still works. Let's actually go look at what this is. Yep, so it throws. That does exactly what we want it to do. Okay. But if you look at the test here, what this is doing is we didn't set any expectations to have perform or work called. So when we call these, they end up calling these methods. In other words, rocks doesn't fail. It says, well, you didn't have to. They're kind of like, if you think of them, well, virtual. Yeah. But if I called ID, it's going to fail, but for a different reason. Like if I say equals mock dot ID, and now I run this test, we should get a failure, but it's an expectation failure is what should happen. So if we look at this, yeah, no handlers match, and that's exactly what we want. Yeah, that's perfect. Okay. Now, here's the kicker. So I think we actually have a solution in place. This will be nice, because I like quick solutions. Who doesn't? Where's my change log? So we're going to put in here, and this will be released with a alpha package first. We don't know when we're going to do that. Fixed. Changed shim implementation to always throw an exception if a member is invoked. And then we reference our issues, which will be 389 and 90. So this will be 389. And then we also want 3 and 3. Yeah, I can't type numbers. Oh my god. All right. So that should fix this. Now, if I go to my tests for the analysis tests, and I say run the tests here, these are some of them are going to fail because it just doesn't match the code doesn't match, which is fine. That's what I'm saying. I think it should be pretty easy to fix these and pretty quick. I do have a hard stop in about 30, 45 minutes. I have to get on a call. So I do have to time box this stream a little bit. But hopefully I'm going to say about 30 are going to fail, because shims don't come up a lot. It's only for default interface member situations. So 5 failed. Actually, that's even better. And I bet they're all in the shim generator. Oh, nullability does. Ah, because we also have a... Okay, so let's actually get into all these. Well, this is a... Yeah. Let's find some text here, because I bet if we say sealed class shim, okay, and then let's go all the way to the top and say fine. There. Now what we want to do here is say throw new global rocks.exceptions.shim implementation exception. Get rid of that. And we're going to do this everywhere. And so now that should pass. Yep. So let's find that again. And we'll come here and do that. And we'll do that here. Find it again. We've got a couple, but neither one of them. This is basically the analysis generated in the code example of the real one, the integration test that actually does this. Since it doesn't generate any, that should be fine. So that one probably didn't fail. This one is just an event, which we don't care about. This one should fail. We want it to do this. Now let's find that again. Why did you suddenly change everything to suddenly look like that? That is bizarre. Yeah, I was like, oh, way to format the code, Visual Studio. That was weird. Okay, so now we need all of these. Yeah, so it will also... Why does it put it on a new line? Whatever, I don't care. It should do the same thing here. Okay. And we're back to that. And then if I go to my test explorer, there was this one. Get my mouse in the center. So there should be somewhere up here. Where are you? Oh, I can just do that again. All right. That's the only spot. So let's go back here now and say run tests. See what happens. And then if these all pass, I'm going to do the classic shutdown, start up again, run all tests, run the code generation tests. If that truly fixes it, then that fixes this bug. So that's going to take another about 5 or 10 minutes. But as I say 5 billion times, testing is important. You want to test all your stuff. So I should also get, once I get back from Canada, I think I'll start playing with 2026 on this machine and seeing what that's like. Because again, I've heard decent things about it. One of the positive things I've heard about it is the speed. I've heard generally it's noticeably faster, which is good. All right, so those all passed. So again, let's just do the shutdown, start up again, close that, do that. 2022 preview, because we need .NET 10 to run. It's kind of weird, like when I find these bugs in rocks, it's, I don't want to say it's oddly satisfying, but it's always that unknown challenge. I've run into bugs previously that have really made me struggle with rocks and really made me have to think very hard on how to fix them. So I haven't had one like that yet, although this one is not out of the weeds because we still need to get all the tests to pass. But yeah, they're definitely, and I think all of them have been educational to some degree. At the very least, seeing what other people do in their code and go, oh, I didn't know you could do that. I don't know if I want to do that. I don't know if I'd ever want to do that, but yeah, you can do that. Okay, so, 3 failed. Really? And the integration tests, oh no, oh no, oh no. Yeah, I had the faint feeling that, yeah, son of a gun. I think I did this before, and I ran into this exact example, and I went, crap. Because it's not going to work. And you make me go, and Jason, why wouldn't this work? It's because in this case, what's happening is I'm making a mock of this type of indexer polygon up here, okay? Which its indexer has an implementation, okay? And so we say on the side length, we're going to return a value of 3. Okay. So then we go, well, on that mock, notice that we're not calling or we're not doing anything on the indexer, right? What's happening now is we're getting a verification exception to following verification failures. It's because get side length is never called now. And why is that? Because if you go to this, well, we don't set an expectation on the indexer. So we come through this and we fall into this. Okay. And this is this shim that I created. I think what we're running into is this case that I have a different, this will actually showcase something. If I say to raw context here and I say disable verification, yes. Now if I run this should fail for a different reason. But you're going to see now it's because of what you get the exception, and then because I got this context with the dispose, it'll say, well, we never called side length, so we're going to say that that's the exception, but it's actually masking the real exception. So that's why I threw this switch on to raw context to say, well, disable that, because what I want to see, did any exceptions occur first before you do verification on the context. And so now you can see that, yes, we are getting that exception because we ended up calling that. And so that I should put somewhere, because I think this is the second time I've tried to do this and it fails. So I'm sitting here going, you know what? I think the best thing to do is do what I said, which is when you need to do an explicit implementation, you put the type there as the cast, not the general interface that I'm deriving from. So this is what's good. This is what's good about branches, everyone, is that I can just roll it all back. Right? We say here, oopsie daisy. And then we'll get rid of the implementation exception thing because that goes by the mind. We don't want that. Okay. Now, the one thing I wish I could have kept, I didn't think about this, but I want to go into generators now and go to shim, builder test. So now I'm going to have to do this 5-minute dance again, which is, no, again, this fix, this is my plan B, and I think this should still be able to fix both of these. Okay, so we want to say test static async task generate when shim has hidden properties. So I don't think I have a test name that already. Or I do. I already do have that. As with both accessors. Oh no, you're complaining because I don't have an await in the method yet. Got it. Okay. We're getting there. So we'll take that. We'll say make here. And then we'll come down here and we'll grab this, and then we'll run the code, and then we'll get the failure, and then I either I'm going to find the stream, or I'm going to find the video I made when I ran into this and went, oh yeah, I ran into this. And I just have to keep in my head, don't change shims. Don't just make them exceptions, because it doesn't work. You have to call the real thing, because that in turn can call other things that you may not have anticipated. So it may work for the properties and, but not the methods or the indexers. So you might as well just solve it for all of them. So anyway, let's run this. Get all the generated goodness. Come on, page down. Let's grab all this. For the content, as they say in the streaming world. Are you throwing this? Like, you see people, are you throwing this game on purpose for content? No, I did not throw this implementation on purpose for content. I thought it might work, but again, I was also sitting there in the back of my head going, I don't think this might not work the way I expect it to. Because I thought I had tried something like that before, and I did. Maybe I should put a note in an architecture document that we'll never read again. Don't change shims to do that, because it never works. Okay, so now we're here, and we should now get the error that I was expecting before, which, if I scroll down here, it is the cannot be assigned to, it's read only. Right? That's the error that we get. Yep, okay. I think I realized too with this one, because this is 389. I think I realized though with this one that, because I'm saying here, it needs to be generated for both, which is true. It's just the cast needs to be with the thing that you're doing the explicit implementation on. So let's go up into the analysis, except this time when we go into shims for the builders, we're going to start with properties first. Okay, so here we're casting to the shim type. This isn't correct. So here we generate the property. Here's the explicit name. And the explicit name ends up becoming how does this work? If there is no explicit implementation needed, you're just going to say public, and there is no explicit name. Otherwise, you're going to say, you don't say public, and it needs to be the properties containing type, fully qualified name. Dot, which we don't want. We don't want to do a dot here because we just want that fully qualified name here. So this works here for the property name. But we're going to want to say something like var cast type name is equal to, and do something very similar to this, except completely different. So we're going to say cast type name. And I guess I could pull these all out, you know, when I... So if it's... yes. Okay, so if it's not a explicit implementation, then we're going to cast to just the shim types that we were given. Otherwise, we're going to cast to this. Okay. And so that is what goes in here. That's what we're going to cast to. Now, I think we had a problem with the emitter. For some reason on the emitter here, we don't do this. We don't do anything at all. And I think the reason why we don't even do anything on the emitter is because on a shim, it doesn't matter. I think there's no way that this would ever matter. I'm kind of curious though, if I set a nid here and we cast to that the property name as a value. One way to find out, right? Okay, so that's the cast type name. If we go into the indexer, we should be doing something very, very similar, right? We should have something like that, except it's an indexer. Yep. And so now here we say the cast is going to be, oh, thank you. Oh, thank you. And then we'll say here init. This would be now init. Okay. And now in the method, that's the last one. We'll want to come down here. This does all the constraints and everything, but this right here is where we want it. So we want to say method. It's a good guess on my part that those names of the variables are that. And so we say here we say cast to that. Okay, now does this actually work? If we go into our code generation test and we say program, we want to go to test with type, and we want to now test against this thing that I marked down here. Do we still get an error or not? Run that. And we don't. Okay. What about 390? What was that type? That type was this one. Nope, just stop. I'm not running any tests here. Did the wrong keystroke. Let's run this. And that works. What about all of our integration tests? They all pass. They're quick as hell because everything's been generated at that point. The other ones, it's doing code comparisons. And this one, I don't know if we're actually going to get any. Yeah, we will, because we just added a test here to this. And so this should have a shim down here that we're saying This is on, it's not because it's a return type, it's because it's actually defined on that. And that passes now. Okay, so let's do the classic shutdown, start up again. Preview. Just gotta make sure we're doing this in preview. So we're restored to everything. Let's run now all the tests and see if we get any failures. Hopefully we don't. It's definitely chugging away. That's something I've never looked at. The other mocking frameworks. How many tests do they have? Could you get 3 fail? Are you kidding me? No, is it the same ones that failed before? Oh, is it because the types? Oh, I just missed these. Okay. Okay, well, that's why we have these things called tests, right? Right? Yeah. Okay, good. Okay, so we should be able to shim thing here. And we should be able to read, because this is I read only key here, that's what does this. And then this one doesn't have any overrides, so this one should now work, I think. Yep. Okay, so it was not a problem. I just missed these, and I just got to update them real quick. What's wrong with this? Oh, because we now have an init. Wait a minute. Right, we say this. Okay. What's the error? That's why I didn't do what I did. Okay. Because indexers can't be initters. And if we come back down here, we can just fix this by saying, I think that's probably why I did what I ended up doing here. Because of something like that. Now if I come back to this, this should work. Yeah, because the only way an initter could even be populated on a shim or needed is if you called something within the constructor that required it. And I think I just went, no. Because that means you've somehow called a virtual method or a member in your constructor, and you should not do that. That's actually, there's lots of, because of what gets initialized in what order can be very messy. And so I think I also just kind of justified all this with saying, nope, you can't do this. So if we ever need to, I can always just come back and make that actually a setter. But that should have fixed that. If I come to this one, I'm guessing it's probably because either we have an initter somewhere. These are getters, and it's because they do this. Yep. Okay. Now all should pass. None shall pass, all shall pass at this point. And then when we run the code generation tests, what we should see is there should be some failures, but that's with a different issue. So there should only be those failures, about 16 of them for one type. And that will be okay. We'll fix that with the next issue, with the next fix. And while we're doing that, we can come back in here and changelog, because I got to add that now. So again, that would be a 10.0.0-alpha 1, not yet released. Fixed. Made all explicit implementations in shim members cast to the type of the explicit implementation. 0 failed, by the way, so that's good. Why did 7 get skipped? Why am I skipping so many? Well, that's that one. I knew about that one. Comparisons. Oh, yeah, I do that because those are just to show the comparisons between rocks, MOQ, and then substitute. Okay. So now we need to say here this is issue 389, right? Yeah, 389 and 390. So we'll say that. And now we'll say 390 here. There. Made all explicit implementations and shim members cast to the type of the explicit implementation. Boom. Now let's run code generation. While that's cooking, we can look at the other issue that we need to fix. And I'm hoping this one isn't too bad. Members should not have unscoped ref on them. So this came up with system numeric tensors. I read-only tensor, and I'm guessing this was added recently. I don't know if unscoped ref is a new thing or has been there all the time. Hi, Ashish. Hopefully I said that right. But I've never run into this before. And so if you have something that has unscoped ref on it, and I actually checked this by putting this type in there and saying inherit from it, generate all the overrides or implementations for it, and Visual Studio will not put the unscoped ref on the implementing class type. So as you see in the error here, it's saying that this attribute can only be applied to structured virtual interface instant methods and properties and cannot be applied to constructors or init-only members, which doesn't really help because I'm guessing it kind of does, because a structured virtual interface instances where if you put it on the mock type, it's now a non-virtual, and so it won't, and so it kind of meets that criteria. Still chugging away. Okay, cool. So, oh, actually, did I just see something? AutoMapper. I gotta take that out actually, because AutoMapper is, I mean, it's for commercial open source stuff, so I guess this could still reference it. I don't use it in any of my code. It's just one of the many targets I have during my code gen test to see if it fails on anything. So I guess I could still keep it in, but yeah, I would need to take it out if I truly am violating the license now. Whatever. Okay, so in any event, this is an attribute that you don't put on the implementing member. And I'm already doing this in some cases. So where I've had to say, if it's on the base type, don't put it on the member in the base type, don't put it on the mock member type, member thing, if that makes sense. So I'm hoping that can be a quick fix. I just have to remember where in the hell I do this. Not in rocks, because it's in rocks analysis now. And of course I'm not going to fix it here because I got to wait till this finishes so I can merge this branch in. So somewhere in my code, I do do I have any tests that say something to the effect of attribute generator tests? I think in this case I needed to add it, right? ToString. Yeah, we wanted to put it there. What am I... Ref parameters and color attribute. Yeah, this one... Hold on.
We're down, and it's beautiful, wonderful. It's heaven, it really is. All probe data confirms observational analysis. Geoscience Officer Tavardi will dispatch a brief preliminary report. Okay, keep it short, Ben. Right, just highlights. Atmosphere is thin but friendly. High oxygen and nitrogen content. Oxygen ratio.
I'm going to have to cut this short because the call might be at 4:30, not 5. Which is fine. I just... So I just have to figure out where I'm not putting in attributes. It's somewhere within this code here in one of these extensions. I don't remember which one though. Can't emit attributes that are compiler generated, not visible to current compilation. Yeah, these things. And so I have a list of these here. And so I say, even if you find these, yeah, remember we implement explicitly and the target type is a parameter and the parameter is optional. We can't emit these 4 caller types. So this is basically what gets me all the attributes for a particular member. But yeah, I have to filter some of these out. Correct. Okay, I do have to start at 5, not 4:30, so that's good. Okay, let's check out how we're doing on our run here. Okay, we're almost close. These just need to finish, and once they finish, we should see how many errors we get. And hopefully we only see that one type of error. Yep. Unscoped rough attribute. That's the only one that we're seeing. So that actually fixed the error that I was seeing before. The test in place, everything works, so now we can commit this. So git commit. We're going to say 390 and 389. Casts and explicitly implemented numbers, shims, explicit. Whatever. That seems to work. We'll commit that. We'll do that to our branch. Give me a second. I can do this on advance here. Push that to that. So now we need to manage branches. And we're on this one. We want to go to target.net10. Check out. And we want to push this one that we just did into 386 target.net10. Yes. We merge that. And say push. Nice. And now we should be able to see on these. Not 391, 390. We should be able to see that we marked them. Yep. So we can close that one. We can say 389 is closed. It's nice to close bugs. We can go to 391. And we can try to fix that one. Okay, so we want to delete that. that. Okay, we're still on 386 target. Okay, so now what we want to do is make a branch off of this, get a new branch off of that. Now we can change that name here. Okay, so again, we need a test. We want to say generate with unscoped ref attribute. Listen. Got to have these tests in here because we want to make sure that we don't regress. That's another reason why you do tests. That you don't change something that inadvertently changed something that you didn't realize. And let's see if I can get this done before I have to jump off the flag. At least get close. I don't like putting myself under time pressures for no good reason, but if I don't get it done, I can finish it off camera. I've already fixed two out of the 3 bugs, so I got that going for me. This would be I-read-only tensor. Okay, so now we got to get the code. We should be able to grab all because it's not that big of a generation. 1, 2, 3, 4, and then we'll put that there, and then that. You see on all of this, selection, on that, and now we grab the one for the make. And once we do that, we can see this 1, 2, 3, 4, that, there, change all that. All right, now we should see the error about unscoped. Right, because that's saying here, yeah, that this, move over here onto this, unscoped ref attribute. So what's saying is if I come down to my mock here, that this should not be there. That's essentially what we're trying to do. So now I got to go back and find in my extensions. Was it here? No, not in the integration test or the analysis test. In the actual analysis, we want to say here. Okay. So we want to say unscoped ref attribute. Essentially, this can't be included on implemented mock members because they're non-virtual, I think. And this gives rise to that error, which is very new. You can tell by the number if it's that starts with a 9. So there. So now we need to say that is one that we do not want to show up. Where's the fault? There it is. Okay, so we want to say here var unscoped ref attribute unscoped mother. Okay, can't do that. Why can't I do that? Because it's one of these that you can't reference by name in a .NET Standard 2.0 project. So what we need to do is one of these things. Is say it's unscoped ref attribute. And if we look at our test, it's in system, diagnostics, code analysis, and then it would be unscoped ref attribute. Okay, now it's saying we don't use it. It's because we're looking at the get fully qualified name doesn't equal this, It doesn't equal this, and it doesn't equal this. And now we want to grab this one, and we want to say it does not equal unscoped ref attribute. Now if I come back here, hopefully this no longer shows up, and this test should pass. And it doesn't. Oh no. Oh, is it because... Why would that be? Wait, what? Oh, wait a minute. Am I looking at the wrong... Ah, yes, here. Okay. I forgot I have to do it on the other one, too. There, now it passes. Okay, and then I'm going to say here, my code generation test, we'll go to program, and we're just going to do a type. Now it types. And then what I'll say here is it should be here. Read-only tensor. So if we do that, we come down to here and we say it's this type. Did that fix it? Yep. Okay. So in the interest of time, what I'm going to do is I'm going to stop here. The last thing I'm going to do in camera is change in the solution items, change log, and we're going to put mocks no longer include unscoped ref in there. Mocks no longer include unscoped ref. That's good enough. And we can say this is issue 391. Okay. Git commit 391 no longer emitting unscoped. I think I put the wrong brace on the end, but that's okay. All right. So yeah, again, in the interest of time, I got something coming up in a little bit, and I got to eat some dinner. So I am going to have to stop the stream here, but we've basically solved all the bugs that I've currently found. And could there be some more? I don't know. You know, as more packages update for .NET 10, and maybe they do some things that I didn't anticipate from the language and or runtime perspective, and how things can sometimes sneak their way. Because like unscoped ref is an attribute, and that relates very, I'm guessing, closely with ref structs, but the fact that it's there makes me go, well, that's great, but how was I ever going to be able to find out about that? Because it doesn't come through as like a C# language thing feature that I've seen. That's one of the things I really wish I could, if I could somehow find out, other than maybe reading docs, which I don't know if they really have official docs on like what a feature does and how it changes things. Some of these things I just stumble across because they get added and somebody does it. I'm like, oh, now I need to change it. But that's not a. It's a good way, and it's really helped me find thorny issues that I need to address. But it'd be nice to be more proactive about them, if that makes sense. At the same time, I usually don't find a ton anymore either. So it is what it is. But there may be more coming in as more libraries update for .NET 10. From a language perspective, I remember reading it. I don't think there's anything in there that made me go, it's going to make Rock stumble significantly. I don't think it will. Next year, C# 15, especially with unions, that's definitely going to require me to do some work. I don't know what or how. If they add in unions, like it looks like they will, again, that's not a guarantee, but if they do, then that might change, because I have to now be aware of what a union is and how that gets generated and how that works its way into the code. So that'll probably one I need to spend time on proactively. So there's always stuff like that. But for now, I'm going to end this stream because I pretty much accomplished what I needed to do. So I want to thank everybody who's either was watching live on the stream or watching in the future. If you have not subscribed to the channel, please do so. We greatly appreciate it. As I'm trying to get to 5,000 subscribers now. So any new subscription helps. So thank you in advance for doing that. If you already subscribed, appreciate you for doing it. I may do a coding stream this weekend, maybe Saturday morning, and maybe getting back to the interceptor idea. Who knows? We'll see how I feel. But I am going to be doing a stream on Friday night, starting a new game up. So if you're interested in what that is, go check that out. That'll be around like 6:30 or 7 at night, Central Time. And maybe doing another gaming stream on Saturday. I do leave for Canada on Sunday, and I'll be gone for 2 days, but I have the rest of the week off next week. So I might do some streams during the day. Because next Thursday, I have a Dream Theater concert. Yeah. And then this next weekend, my wife and I are celebrating our anniversary. It's technically this Saturday on the 20th. So 28 years married. So good on that. Love you, Liz. And because of the Canada trip, we usually spend a weekend celebrating our anniversary. We get a hotel. We'll go to a nice dinner on a Saturday night. Get an Uber to drive us around so we don't have to worry about that. And it's worked out really nice the last, I'd say 10 years we've been doing that. So now my kids are older, so they don't need a babysitter. They don't need somebody to watch them, which is great. But anyway, that's my schedule coming up in the near future. So hope to see you in a future stream. Thank you for watching. Take care. Hope to see you in the future.